morning to all. I am Dr. Devasis Mohanty, working as assistant professor in the Department of Mathematics, SR University, Warangal, India. So today I am going to teach about the exponential distribution. So exponential distribution has huge application in the field of real life and in field of engineering, medical sciences, as it calculates the waiting period. Okay, so it is very interesting and very applicability, a huge applicability in real life. So today we will discuss about the exponential distribution, how we are going to use the exponential function and how we are using the rate parameter and how we can calculate the waiting time period. This is going to be very engineering application oriented things. So let us start the today's lecture based on exponential distribution. Okay. So this is the definition, students. This definition told us about the exponential distribution. So exponential distribution, that is a continuous probabilistic distribution commonly used to model the time until the event occurs. So generally it calculates the time period. Exponential distribution is calculating the time period. Which time period? Waiting time period. Waiting time period. And it is a continuous probabilistic distribution. So as you know, students, two types of probabilistic distribution are there. One is discrete, and one is discrete, another is continuous. So here it is a continuous because it applicable for the intervals. Okay. Okay, students. So let us start the definition that continuous probabilistic distribution that used to model the time until the event occurs, such as waiting time or lifetime of a component. So the formula is so here you can see the formula of that. That means the exponential distribution f of x equals to lambda into e raised to the power minus lambda x, following x is greater than equal to 0 and 0 when x is less than 0. And students, here lambda, that is the rate parameter. Lambda is the rate parameter. And time of x value is the time or waiting period. Waiting period. So here we are using two components. One component is the rate parameter and another component is the waiting period. Okay. So based on two components, we will calculate the f of x value, that is the exponential distribution. Okay, students. So next, coming to next point. So this is using the cumulative distribution function. Already you know about the probability density function. What is the probability density function? Yes. So there are the condition that integration minus infinity to infinity fx of x dx equals to 1 and fx of x, that is always greater than equal to 0, non-negative, and this value is 1. So it is also using the probability density function condition, okay, to explain the exponential distribution. So here we can calculate it. So we can find the expectation. So you know what is the expectation? That e of x equal to, yes, tell me, integration 0 to infinity x into f of x dx, right? So just we need to multiply the x in the probability density function f of x to calculate the expectation. So here we will derive the expectation in case of the exponential distribution using the rate parameter and waiting time period. Rate parameter is lambda and waiting time parameter, waiting time period is x. Okay, students. So that will apply the f of x value here. So we will get the expectation as e of x equals to integration 0 to infinity x into, in the place of f of x, will apply lambda into e to the power minus lambda x dx, that value. Okay, students. Next, we will apply the integration by parts. So all of you know about integration by parts. So two functions will be there. We need to calculate the integration of that using the first function and second function and substitute it. So here we are substituting the u value as x, so that the derivative du equals to dx, and v value as minus e to the power minus lambda x, and dv equals to, we need to find the derivative, that is lambda into e to the power minus lambda x dx. Okay, students. Now, after choosing this value of u and v, we need to find substitute this. So, if we are going to substitute using the integration by parts, that integration u into dv that equals to uv minus integration v into du. So here we are substituting this value and we are getting the expectation of x equals to 1 by lambda. So please remember that in the case of problem that we will discuss how to find the expectation using the exponential distribution. So expectation is 1 by lambda. So as we know, then if the expectation is 1 by lambda, then the variance, how we can calculate variance of x equals to expectation of x square and expectation of x whole square minus. So subtraction. So that we will find that 2 by lambda square minus 1 by lambda whole square, that is equal to 1 by lambda square. So variance is 1 by lambda square, expectation is 1 by lambda. So please remember this. This is very important, that the expectation of x in case of the that exponential distribution, that is 1 by lambda, and variance of x, that is 1 by lambda square. Okay, that's how it is derived. I already discussed. So remember these two, that those two are important. Okay. Next, coming to the problem. So very interesting problem is there. So try to focus in the problem. A random variable x follows an exponential distribution with lambda equal to 0. So lambda value equals to 0.5. What is lambda? Yes, lambda is the waiting time period. Okay, so we need to calculate the probability of x greater than 3. So here a random variable x follows an exponential distribution with lambda equals to 0.5. Random variable, do you know random variable? Okay, so that x value. So here you can see. So you need to calculate exactly the lambda value is given. So we need to calculate probability of x greater than 3. That means after 3 hours. So after 3 hours means whenever any after case is coming, we need to calculate the probability of x, capital X, greater than small x. That formula we need to apply e to the power minus lambda x. Okay, any after time, if after the waiting period, if we are going to calculate after waiting period. Okay, students. So after the waiting period, if we will calculate, that is the value probability of x greater than 3, that is equal to e to the power minus lambda. So lambda is 0.5. So e to the power minus 0.5 multiplied by x value. X value means waiting time. So that is 3. So that is equal to e to the power minus 1.5. This value equal to 0.2231. Okay, so this is a short problem. Now deeply we'll go to the problem so that you can understand how to apply this exponential distribution and how to calculate the waiting time period. So read the a second example carefully. The lifetime of a bulb follows an exponential distribution with mean 1000 hour. So here the mean is given 1000 hours. From that we can calculate the lambda value, right? Waiting time period, that is 1 by 1000. Okay. Next, find the probability that the ball fell within 500 hours. Okay. So let's see how to calculate this. Okay, students. So here we need to find the probability of x less than 500. That, so here within the time period we need to calculate. So in case of within the time period, within any time period we are calculating. So we will follow the formula 1 minus, see here. So we need to calculating the within that time period. So within that time period, 1 minus e raised to the power minus lambda x. After the time period, e raised to the power minus lambda x. So that are very important. So now here we need to find this value. Just see that 1 minus. That means probability of x less than equal to 500 equals to 1 minus e raised to the power minus lambda x. So here the value is given. My lambda value is 500 and x value is 1000. So 1 minus e raised to the power minus 0.5, that is 1 minus 0.60, that is 0.39 we are getting this value. Okay, so by this way you can calculate the within that time period. That is very important. Within 500 hour, that answer we are finding 0.3935. Okay, students. Next, coming to the next problem. This is very important. Try to understand this question carefully. The time between server failure in days follows an exponential distribution with mean 20 days. So mean is given 20 days. So whenever mean is given, the lambda value means waiting period will calculate 1 by the mean, that is 1 by 20. Okay. Next, coming to the question, what they are asking about, try to understand this. So try to understand the word within. Within any period means what is the formula? I already told you 1 minus e raised to the power minus lambda x within that time period. So that is equal to 1 minus e raised to the power minus lambda value is 1 by 20 into x value. X value is 10. So that is equal to 1 minus e raised to the power minus 10 by 20. That is 0.3935. This value. Okay, students. Then in the question number B, this question, the probability we need to find x greater than 30. X greater than 30 means, so greater value that we need to follow the formula e to the power minus lambda x. So here we are applying e raised to the power minus lambda is after 30 days. So x value is 30 into lambda value. So x value is 30, lambda value is 1 by 20. So that equal to e to the power minus 30 divided by 20, that equals to e raised to the power minus 1.5, that is 0.2231. Okay, so within 10 days, this see this question, within 10 days we are going to find, that is 0.3935, and after 30 days we found that 0.2231. Okay, so this way we can calculate within the time period and after the time period. Okay. So coming to the next problem, see the example 4. So try to understand this question carefully. A factory produces an electronic components, and defective components occur randomly at an average rate of 3 defects per hour. Try to understand this one. Here it is 3 defects per hour. So per hour the defect is 3. Assume that the time between successive defective components follows an exponential distribution. So it follows an exponential distribution. It is mentioned in the question. So from the question, that you can get the concept that we need to apply the exponential distribution here. And the first question is asking about what is the probability that the time between two defective component is more than 30 minutes. More than 30 minutes. It is about the first question. More than, try to understand the term. And second question, what is the probability the next defective components occurs within 20 minutes? So this is a very good question. So we'll discuss that. First question we'll discuss. Directly we'll apply the formula. So here, first question is between two consecutive defective components. So the x value is the exponential, that lambda value equals to 3, because already in the first, see this one, the defect is 3 defects per hour. So here lambda value equals to 3. Okay. Now we need to find the probability of x greater than 0.5. We need to calculate this, the probability of x greater than 0.5. So more than 3 hours, that means we need to apply the formula. What is the formula? E to the power minus lambda x whenever the time exceeding the waiting period. So that we need to calculate. So e to the power minus lambda value is 3 multiplied by x value is 0.5. So that is e raised to the power minus 1.5 we are getting here. So that is equal to e raised to the power minus 1.5. And this value e raised to the power minus 1.5 is 0.2231. Okay. In the second question, try to understand the second question. Probability of x less than equal to 1 by 3. Why it is 1 by 3? Because 20 minutes. 20 minutes. So 20 minutes means we can apply that here we convert the minutes into hour because the x is time in hour, that is in hours. So hours means 20 minute means 20 divided by 60. So that is 1 by 3. And in the first question, it is about 30 minutes. 30 minutes means here it is 0.55 divided by 30 divided by 60. That is 1 by 2. That is equal to 0.5. 0.5 hour. Here it is 1 by 3 hours. But we need to calculate within that time period. So within that time period means probability, we need to calculate probability of x less than equal to 1 by 3, that equals to 1 minus, we need to apply that formula, 1 minus e to the power minus lambda x, right? So 1 minus e raised to the power minus lambda is 3 multiplied by x is 1 by 3. So that is 1 minus e to the power minus 1, that is 0.6321. So this value we are getting here. Okay, students. So again, I am explaining this question. Try to understand this carefully. A factory produces electronic components and defective components occur randomly at an average of 3 defects per hour. So it is mentioned in the question per hour. It is calculating that. Assume that time between successive defective component follows an exponential distribution. So it follows an exponential distribution means waiting time period we need to calculate. So first question is asking, what is the probability that the time between two defective component is more than 30 minutes? And second question, it is about what is the probability that the next defective component occurs within 20 minutes. So two cases are there. Okay, students. So two cases are there. So here more than 30-minute case is there. More than 30 minutes we need to apply this formula e raised to the power minus lambda x. Here within a certain time period, so 1 minus e to the power minus lambda x. But it is given 30 minutes. So 30 minutes means we need to the general average rate is per hour. So 30 minutes means we need to calculate that 30 divided by 60. So that is equal to 0.5 probability we need to find x less than 0.5. Okay, but here it is 20 minutes. So 20 divided by 60, that is 1 by 3. The probability of x less than equal to 1 by 3. You need to calculate. Okay, students. So that value only we are calculating. So this type of question will come in the exam. So you can directly calculate using this formula, which I have recently explained. Okay. So this is the answer actually 0.2231, and second one is 0.6321. Okay. So here another problem is there. The waiting time for service at a counter follows an exponential distribution with rate 0.2. So here this value lambda value equal to 0.2 given. Find the mean. What is the formula? 1 by lambda. 1 by 0.2, that is 5, right? Okay. So, second question, this is about the first question. Find the mean of the waiting time. Mean is 5. Okay. Next question is given. Try to understand it. Find the probability that a customer wait more than 10 minutes. More than 10 minutes. More than 10 minutes means we need to apply the formula e to the power minus lambda x. Between the period also we need to apply. So let's see the solution procedure. So here, given that value, the waiting time x value in minute and follows an exponential distribution with rate. And so lambda value equals to 0.2 per minute. Okay. And the PDF means probability density function. F of x equals to, we need the formula. We already know the formula. Lambda into its power minus lambda x when x is greater than equal to 0. Okay, students. So next coming to we need to calculate the mean of the waiting period, waiting time. So mean of the waiting time, mean waiting time need to calculate. that value is 1 by lambda, that is 1 by 0.2, that is 5 minutes. Already I have explained this. So you know that expectation of x, that is 1 by lambda, variance of x, that is 1 by lambda square. So here we need to when we are calculating the mean of the waiting period x, that is expectation of x, that we need to apply the formula 1 by lambda, that we will get 1 by 0.2, that is equal to 5 minutes. Okay. So this is about the first question. Just apply the formula how to find the mean of the waiting time, then just calculate the expectation of x. Next, coming to the important thing, that is the probability that a customer waits more than 10 minutes. So more than 10 minutes, we need to calculate. More than 10 minutes means probability of x greater than 10. So we need to apply the formula e raised to the power minus lambda x. That is e raised to the power minus, what is the lambda value? Yes, tell me. 0.2 multiplied by x. X is 10 because here it is, we need to calculate more than 10 minutes. So that value we will find e raised to the power minus 2. Next, whenever we are calculating probability of x greater than 10, the value is e raised to the power minus 2 is how much? 0.1353. Okay, so this value 0.1353. This is the probability that a customer wait more than 10 minutes. Okay, students. So next, coming to the next question. Probability that the waiting time lies between 5 and 15 minutes. So that value you need to see. So between those time period. So this is very important. Between those two time period are given. That means 5 less than x less than 15. That means this value, x value, this distribution value lies between 5 minutes and 15 minutes. So that we can calculate by using the probability of x greater than 5 minus probability of x greater than 15. So that value is e raised to the power minus 0.2 into 5 minus e raised to the power minus 0.2 into 15. So that is e raised to the power minus 1 minus e raised to the power minus 3. You can see here. So e raised to the power minus 1 is 0.3679. Just check that value in your calculator. E raised to the power minus 3, that is 0.0498. So that value we will find 0.3181. So this is the value 0.3181. This value is the waiting time that lies between 5 and 15 minutes. Okay, so this is very interesting thing because we can calculate after the time period, we can calculate between two time periods, we can calculate the mean variance of the waiting time period. So that whenever we are waiting for something, so that we can calculate the period, so that we can do some work at the time. Okay. Now these are the practice problems. So try to understand the question. First of all, read the question carefully. The time in hours between successive arrival, and here given the exponential distribution, here given the exponential distribution that lambda value that is equal to 4. Okay, with rate parameter, that lambda value is the rate parameter. So it is given that lambda value equals to 4. Find the probability that the time between two arrivals exceeds 30 minutes. So exceeds 30 minutes, we need to calculate. So probability of exceeds 30 minutes, x greater than 30, we need to calculate. Okay, that means it is given the exponential distribution in hours, so we can convert it. So 30 minutes means 30 divided by 60. So that is equal to, already we have solved about that. So we need to calculate probability of x greater than equal to 1 by 3. That value. So exceeds that value means we need to apply e to the power minus lambda x. Okay. So we can calculate this value. So e to the power minus lambda x we need to calculate. That means probability of x greater than equal to 1 by 3. that value e to the power minus lambda. Lambda is minus 4 into 1 by 3. That is e raised to the power minus 4 by 3. Okay. Next question is asking about, try to understand the question. Find the probability that the next arrival occurs within 10 minutes. So we need to calculate the within that period, within 10 minutes. So 10 minutes means in hour it is 10 divided by 60, that is 1 by 6. So within that period we need to calculate, means any within time period we are calculating, we need to apply the formula e1 minus e to the power minus lambda x. So that is equal to 1 minus e to the power minus lambda is 4 and x value is 1 by 6. This is 2, this is 3. So 1 minus e to the power minus 2 by 3. That value, just calculate this. Then find the expected time between the arrival. Expectation. Expectation means E of x equals to, what is the formula? Tell me. Yes, E of x equals to E of x expected time equals to 1 by lambda, that is 1 by 4. Okay, 0.25, right? 0.25 or 15 minutes also we can say. This 0.25 or 15 minutes. This first answer, just to verify the answers. This first answer is 0.1353, second answer is 0.48666, answer is 0.25. Okay, this is about the first question. Second one, defects in a wire occurs randomly with a distance in meter between the defects and the lambda is given, that is 0.05. This lambda value is given 0.05. And we need to calculate the next defect occurs after the more than 50 minutes. Okay, so more than means what you need to calculate, e to the power minus lambda x. Okay, in meters. In meters, the distance is given in meters. So we need to apply this formula. So we'll get the result 0.0821. Just to verify the answer. Okay, students. So this is all about that problems. So next, come to next problem. So the third question. So that is the lifetime in hour of an electronic component follows an exponential distribution with mean equal to 5 hours. Then we need to find the rate parameter lambda, that is 1 by 5, that is 0.2 per hour. Here you can see the answer. Second question, find the probability that more than 6 hours. More than 6 hours. So more than 6 hours means what? You need to calculate greater than 6. More than e to the power minus lambda x. So e to the power minus lambda is 0.2 multiplied by x. X value is 6 hours. 0.2 into 6. So this value e to the power minus 0.2 into 6. 0.3010. Then last question. Last question is asking about, find the probability that the component falls within 3 hours. Within 3 hours means the probability of x less than equal to 3 within that period, that we need to calculate 1 minus e to the power minus lambda x. So that is 1 minus e to the power minus lambda is minus 0.2 multiplied by 3. So that is equal to 1 minus e to the power minus 0.6. That value is 0.4512. Okay, students. So easily you can calculate. So this is all about the exponential distribution. So the problem, three problems, practice problem is we have discussed already. We have discussed and discussed the example also. Thank you for listening this. So this problem. So if you have any doubt, please ask me. Yeah. So this is all about the problem. So generally, means we need all in this exponential distribution, we are calculating that continuous probability distribution, calculating the waiting time period. So this is very important. Waiting t time period we are calculating here. So waiting time period means the rate parameter that lambda value is using two values, mainly two values. So one value is your that rate parameter. So in all the problems we are using that rate parameter lambda value and time period, waiting time period, time or waiting period. Basically, we are called it as waiting period because the waiting period where we were calculating this x value. That means probability of x less than small x that we need to calculate. Okay, these are very interesting topic. So you can follow this lecture to know more about the exponential distribution. So here we have discussed about how you can find that expectation is 1 by lambda and variance is 1 by lambda square. And some problems are there, and already we have discussed about those problems. So through these problems, we can easily calculate that time period, waiting time period. Okay, directly this question is direct actually. But generally in examination, we will find that within that time period, we need to calculate this value. Okay, so try to understand the two things very carefully, because for some question it is given more than that time. So more than that time, in case we are just put this formula e raised to the power minus lambda x within certain time period, just put this formula 1 minus e to the power minus lambda x. The two things we need to put and we need to calculate. Okay, so these are very easy concepts which you can follow. This time, this problem also we have discussed. So in this problem also we have seen that how we can calculate. So lambda value, if the mean will be given, so in the question it will be asked how to find the lambda value. So whenever it is asking like that, so you can easily find the lambda value because the lambda value is the rate parameter, right? So rate parameter means the mean is given. Suppose mean is 20 days. Here it is given 20 days. That means lambda value rate parameter will be 1 by 20. Whatever the mean is given, 1 by that value, only we need to calculate. So we'll find that. Okay. Well, suppose it is 10, so 1 by 10. Suppose it is 5, so 1 by 5. Like that. Mean is given means lambda is 1 by that value. Okay. And then within that time period or after any time period, it will be given in the question. So we need to follow whatever we discuss in the lecture class. We need to follow that so that we can find the values, right? So as it is video within 10 days, within 10 days means x less than equal to 10. That is e to the power minus lambda x. That formula we need to apply. But after 30 days, that means greater than 30. Greater than 30 means we need to formula e to the power minus lambda x here we are applying. Within that period means 1 minus e to the power minus lambda x. So these are the things we need to discuss. So all examples we have already discussed and the problems. So this is all about the exponential distribution. So all of you, thank you for listening this lecture. So next class we will discuss more about it. So thank you for listening. Thank you all.